So next conversion is binary to octal conversion. So by grouping 3 bits of binary numbers and converting each group of bits into its octal equivalent, we can convert binary numbers into octal equivalent. So for example, 10101101.0111 base 2 binary number, if you want to convert into octal, so what we have to do is we have to start grouping these numbers into group of 3 bits. For the integer part, we have to group from this LSB to MSB, group of 3 bits. Grouping should be done from LSB to MSB. And for the fractional part, it should be from the MSB to LSB. That means for the integer part, it should be towards left side. And for the fractional part, it should be towards right side, grouping. That means from the binary point, first 3 bits, 101, one group. Then the next 3 bits, 101, next group. Then at the end we have 10, but to make it as a group of 3 bits, we have to add 10. So by adding 10, we are making it into a group of 3 bits. And then the corresponding octal number we need to write. 010 is 2, 101 is 5, 101 is 5. Point. Again, after this binary point, for the fractional part, grouping should be towards the right side. So first group will be 011, 011. Then here we have only one bit left, only one bit. But to make it as a group of 3 bits, we are adding 2 zeros here. So that this group will become 100. Then the corresponding octal number 011 is 3, and for 100 it is 4. So the final answer will be 255.34 base 8. So we will see one more example. 1011.01 base 2 we want to convert into octal. So here also, before this binary point, grouping should be towards left side. After the binary point, grouping should be towards the right side. So if we group this for the integer part, first group will be 011, say 011 first group. Then there is only one bit left, one bit 1. So to make it as a group of 3 bits, we are adding 2 zeros here, so that it is becoming 001. And for the fractional part, only 2 bits are there, 01. To make it as a group of 3 bits, we are adding 10 here. Then we are writing the corresponding octal number. So first group is 001, which is equivalent to 1. Then 011, which is equivalent to 3. 0.010 is 2. So the answer is 13.2 base 8. Now the next conversion is octal to binary conversion. So if you want to convert octal to binary, for each octal digit we are writing 3-bit combinations of binary. Okay, so it is very simple. For each octal digit we have to write 3-bit combinations in binary. So for example, if you want to convert 125.62 base 8 to binary, for each digit, first digit is 1. So 3-bit combination of 1 is what? 001. Then 3-bit combination of 2, 0, 1, 0. Then 3-bit combination of 5, 1, 0, 1. Point. For the 6th 3-bit combination is 1, 1, 0. And for 2, it is 0, 1, 0. So this is the final answer, which we are getting binary equivalent of this given octal number. Same way, 37.4 octal number, if you want to convert into binary, for the 3-bit combination is 011. For 7 it is 111. Point. For 4 it is 100. And we can eliminate the zeros, trailing zeros and leading zeros. So the final answer is 11111.1 base 2. So the next conversion is binary to hexadecimal conversion. By grouping 4 bits of binary number and then converting each group of bits into its equivalent hexadecimal, we can convert binary number to its hexadecimal equivalent. For example, this is the binary number given. Here also, before this binary point, grouping should be towards the left side. After the binary point, grouping should be towards the right side. And we have to make a group of 4 bits each. Okay. So for the integer part, if we start grouping from here, 0, 1, 1, 1. This is the first group, 0, 1, 1, 1. And the second group is 0, 1, 1, 0. And in the last group, there is only 1, 1 left. So to make it as a group of 4 bits, we are adding 2 zeros here. So we got 3 groups of 4 bits each. Then after the binary point, grouping should be towards the right side. So the first group will be 1001. Then we have only 3 bits, 101, 101. but to make it as a group of 4 bits, we are adding one 0 here. So we got, for the fractional part, we got two groups of 4 bits each. Then we need to write the corresponding hexadecimal number. So here the first group is 0011, which is equivalent to 3. Then we have 0110, which is equivalent to 6. Then we have 1110. 1110 is what? It is equivalent to 14, but in hexadecimal it is E. And after the binary point, first number is 1001, which is equivalent to 9. Then we have 1010. 1010 is 10, but in hexadecimal 1010 is equivalent to A. So the final answer is 36E.9A base 16. Now, if we take one more example, 10100.11 base 2. So again, we have to start grouping from the binary point towards the left side, after the binary point towards the right side. So here for the integer part, first group will be 0010. This is the first group. Then we have only one bit 1. To make it as a group of 4 bits, we are adding 3 zeros here. So 0001 first group, then 0100 second group, and after the binary point only two bits are there, 1 1, but to make it as a group of 4 bits, we are adding two zeros here, so this is becoming 1100. Then the corresponding hexadecimal number. So here 0001, hexadecimal value is 1. Then we have 0100, which is equivalent to 4. Then 1100, 110 is 12. 12 is nothing but C, so we are getting C. So the answer is 14.C base H. Now, if you want to convert any hexadecimal number to binary number, what we need to do is, for each hexadecimal value, we need to write the 4-bit combinations of binary. So here, for example, 8A9.B4 hexadecimal number we want to convert into binary. So for each digit, we are writing 4-bit combinations of binary. So 8, first digit is 8. For 8, 4-bit combination is 1000. Then we have A. A is nothing but 10. 10 is what? 1010. Then we have 9. 9 binary, 4-bit combination of binary of 9, 1001. Point B. What is B? B is equivalent to 11. 11 is what? 1011. Then we have 4. 4 is what? 0100. Then we can eliminate the zeros at the starting and ending here. So the final answer we are getting this base 2. One more example will say 4A.3C base 16 we want to convert into binary. So the first digit is 4. For the 4-bit combination is 0100. Then we have A, which is same as 10, and the 4-bit combination of 10 is 1010. Point. Next number is 3 here. 4-bit combination of 3 is 0011. Then we have C. For this C, the binary number is what? 1100. Then we can eliminate this 0 in the starting and these two zeros at the end, and then we'll get the final answer. Then next we will see how to convert octal to hexadecimal and hexadecimal to octal. So if you want to convert octal to hexadecimal, first we need to convert octal to binary and then binary to hexadecimal, which we already discussed. So for example, if you want to convert 615.25 base 8 to base 16, first we need to convert this octal number to binary. How to convert octal number to binary? We need to write 3-bit combinations of binary. For the digit 6, the 3-bit combination is 110. Then for 1, it is 001. Then for 5, it is 101. Point. Next number is 2. For 2, 3-bit combination is 010. And for 5, 3-bit combination is 101. So we converted this octal to binary. The next step is we need to convert this binary to hexadecimal by grouping into 4 bits, okay? And before the binary point, starting from here, 1011, see here, 1101. Then we have 0001, see here, 0001. Then only one bit is left there. To make it as a group of 4 bits, we are adding 3 zeros. And after the binary point, the first group is 0101, that is the first group. Then only 2 bits left to 0 1. We are adding 2 more zeros to make it as a group of 4 bits. Now we need to write the corresponding hexadecimal values. So first group is 0001, that is equivalent to 1. Then we have 1000, which is equivalent to 8. Then we have 1101, which is equivalent to T. Then after this point we have 0101, which is equivalent to 5. Then we have 0100, that is equivalent to 4. So this is the hexadecimal value. If you want to convert any hexadecimal to octal number, First we need to convert hexadecimal to binary and then the binary to octal. So for example, BC 6.AF base 16, if you want to convert to octal, first we are converting this hexadecimal number to binary number by writing the 4-bit combinations of binary. So for the first number, first digit B, the 4-bit combination is 1011. For C it is 1100. For 6 it is 0110 point. For A it is 1010, and for F it is 1111 base 2. So we converted this hexadecimal to binary. Now we are converting this binary to octal by making groups of 3 bits. Okay, for before this binary point, the first group will be 110, then we have 000, then we have 111, then we have 101. And after the binary point, first group will be 101, then we have 011, then we have 11. So to make it as a group of 3 bits, we are adding 10 here, so that this will become 110. Then the corresponding octal numbers we are writing. For 101 it is 5, 1117, 0000, and 1106. After the binary point, 1015, 0113, 1106, so that we are getting the octal number of the given hexadecimal number.